Hey everybody, this is Miss Doolittle, and I wanted to do, hopefully this one will be a short video on product of powers. Okay, so product of course means multiply, and then powers is when you have a base with an exponent. So let's jump in and get started. All right, so the gist of this whole thing is when the bases are the same. Okay, so this is really important. When the bases are the same, we are going to add those exponents together, and I'm going to show you why. Okay, so if we look down here at x to the fifth, of course we know, and we talked about this in the last video, that x to the fifth power means I'm going to use my base of x as a factor 5 times. So x times x times x times x times one more x. There we go. There's my 5 x's. Now, I've got this multiplication symbol. I'm going to bring this over here, and just for dramatic effect, I'm going to make that really big so you guys can see that's what separates my two powers. By the way, when you have an exponent and a base together, that's considered to be a power. Okay, so this is going to be times x to the third power. Now, of course, what x to the third power means is I use my base as a factor 3 different times. Factors just means things that are multiplied together. So x times x times x. Well, look at the end result here. What do I have? I actually have created a string of 8 x's being multiplied together. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the shortcut way to write that with exponents is x to the 8th power. All right, now here's the thing. You can do this over and over and over again with expanding each one of these powers and seeing what you end up with. But the shortcut that's going to make our lives a whole lot more efficient when it comes to this stuff is to recognize that all we have to do is take these exponents and we add them together, and that's what ends up giving us our x to the 8th power. Now, of course, the mathematical reason behind that is all of this that we just went through. Okay? All right, now, here's the thing. I wanted to do another one for you where my bases are not the same. I want to expand this for you so you can see what this does. So x to the 4th power, that means I use x 4 times as a factor, times. And then y squared, that means I use y 2 times as a factor. Okay? Now, if I want to write this the simplest way that I can, right, what can I do here? Can I write this with one exponent, given that I have 4 x's and 2 y's? There's really no way for me to do that. So up above, the reason I could do that is because my bases were all the same. All of these factors were the same thing. But down below, that's not what I have. So the best that I can do here is still to write this shorthand is to say x to the 4th power and y squared. That's really all that I have, all right? So this is as simplified as it can get. So this x to the 4th y squared, which is essentially the same thing you saw over here, I'm just not showing the multiplication sign, is as simple as I can write this. But in contrast, this x to the 5th and the x to the 3rd power, those, because the bases are the same, can be written in one single expression of x to the 8th power. Okay? All right, now I want to show these to you with numbers as well, because sometimes these tend to throw people a little bit. So here's the thing. We've got a base to a power times base to a power. My bases are the same. Again, I can write this out for you. So 2 as a factor 3 times 2 as a factor 5 times. Didn't get very creative there with my numbers, did I? It was exactly the same as the first one. But if you look across here, I'm using the same base every single time, or the same number as a factor every single time. And how many times am I utilizing it as a factor? Well, 8 times, okay? And off the top of my head, I don't know what 2 to the 8th power is. I probably should know that, but I don't. But we could punch that in a calculator and find that easily enough. I'm not going to take our time on this video to do that, though. Now, again, by contrast, I want you to look at what I have down below. So this is 4 to the 2nd power. Well, of course, that means 4 times 4, 2 4s. times, I'm going to use 3 now as a factor 3 times. 1, 2, 3. Okay, so again, there's really nothing I can do. I certainly don't want to take 4 times 3 and then raise that to like the 6th power or the 5th power or something crazy like that. We really don't want to do that. So what we have to work off of here, we really have to use order of operations with this since our bases aren't the same. So I almost have to go back to my original of 2 4s times 3 3s. Now, remember, in order of operations, PEMDAS, exponents comes before multiplication. So that means I need to simplify my exponents first. 4 squared, 4 to the 2nd power is 16 times 3 to the 3rd power is 27. And again, I have no idea what 16 times 27 is off the top of my head, but we could multiply that out with a calculator, okay? But this is the only way that I can simplify this problem because my bases are not the same, okay? So this goes right back up to the rule. When the bases are the same, you can add the exponents. All right. A few problems here for you. Some of these, a little bit different types of problems. So I'll start you off with this first one, and then you guys can pause the video at any given time and sit and try to work out these problems on your own, and then make sure you press play so we can check your answers because I will go through each and every one of these. Okay, so here's the thing. What this means is I've got a 2 times m times m, 2 m's, and then a 2 times m times m times m, 3 m's, okay? So this is just a bunch of things being multiplied together is really what this is. 2 times m to the 2nd power, I'm going to go ahead and do the shorthand way with the exponents, times 2 times m to the 3rd power. Well, one way you can look at this, and you won't have to write all this out once you get used to it, but I'm going to show you just so you can see it with your eyes. I can write my 2's together and then my m terms together, or my m factors together. Okay, 2 times 2 of course is 4. Multiplication is still going to work the same way that it always has for us. And then m squared times m to the 3rd. Remember, because my bases are the same, I can add my exponents together. So this becomes m to the 5th power. So number 1 simplifies to be 4 times m to the 5th power. All right. If you want to pause the video and try number 2, that'd be great. We'll check when you get back. Okay, hopefully you had a chance to do that. This is a 1m to the 4th power times 2m to the negative 3rd. 1 times 2, of course, is 2. We're just going to multiply our numbers together like we always would have. And then m to the 4th times m to the negative 3rd is just going to be m to the 4 plus negative 3 power. Well, that is 2m to the 1st power. And of course, I don't have to show an exponent of 1. Again, that whole idea of phantom 1. It doesn't have to show up when it doesn't want to, but it's still hanging around. It's still there. All right. You guys can go ahead and pause the video and work out number 3. We'll check when you get back. Okay, here we go. 4 times 2 is 8. I've got a variable of r. My bases are the same, so it's negative 3 plus 2. That means I can add my exponents because my bases are the same. So the 8 is going to remain an 8. My r is going to remain an r, but what is my exponent? Became a negative 1. Oh boy. Okay, now so we have an exponent of negative 1 in our answer, but to completely simplify that, we have to apply what you guys learned earlier in this module, that the 8 is going to remain in the top level of the fraction, but this negative in the exponent means take my base and my exponent and move it to the other level of the fraction. And hopefully you notice I drew my exponent as a dotted one because, again, just like up here, except I didn't draw the dotted one, it's a phantom 1, right? It doesn't always have to show up. So this could be written just as a plain old r, and we would understand that that phantom 1 exponent is still there even though we can't always see it. All right. Number 4, pause the video, work that thing out. Okay, let's check. 4 times 2 is 8. Both of my variables, my bases, are n's, so I'm going to add the exponents. 4 plus negative 3. This is 8n to the first power. But again, my exponent of 1 does not have to show up. It can be a phantom one. Stay hidden. All right, let's give number 5 a shot. Okay, let's see what we got here. 2 times 4, again, is 8. All right, and then we have, this time we have a k for our variables. Okay, so our bases match, they're both k, but what you have to recognize is, again, phantom 1, this is actually an exponent of 1. That is a k to the first power. So this is going to become 8k to the 4 plus 1, which is 8k to the 5th. Obviously, the big mistake that a lot of people would make on a problem like this is they would forget, because they don't see the exponent hanging there, and they would forget to add that 1 to the 4. But it is, in fact, a k to the first power, so we would have to add that 1 to be correct about this. Okay, go ahead and work out number 6, and we'll check your answer when you get back. All right. Okay, so 2 times 2 is 4. And then we're going to have my bases of x have exponents of 3 plus negative 1. My bases of y have exponents of negative 3 plus 3. So let's rewrite this and simplify. That's 4, and 3 plus negative 1 is 2. And then a y, but negative 3 plus 3 is 0. So that's a y to the 0 power. What did we learn about earlier in the module? Anything ever, ever, ever to the 0 power is 1. So that would end up just being a 4x squared, and then I could write a times 1 over here, but you can multiply by 1 all day long and it doesn't change anything. So this just turns into 4x squared. All right, there you go. That is how you work these problems. Thank you so much for watching, and if you have any questions, please don't hesitate to shoot me an email. Thanks so much. Bye-bye.